Okay, after proving the Pythagorean theorem, uh, the little packet jumps all the way out here. It says use the Pythagorean theorem to find the unknown sides of each triangle. All right, that is fine, but we forgot a few things here on this worksheet. First thing is this part. We need a right angle. Right angle. The Pythagorean theorem only works for right triangles, so we definitely need this little indicator right here. And also, let me see, a squared plus b squared equals c squared. This c is always the hypotenuse. I'm just going to say always the long side. Just to make sure we're not misusing the Pythagorean theorem in some weird cases. All right, now we can apply it to this triangle here. So, a plus b, it doesn't matter which one we call a, which one we call b. So I'm just going to call that a equals 5, and I'll say the 2 is the b, and the c will be my x. All right, so I'm just going to substitute into our Pythagorean theorem and start with 5 squared plus 2 squared equals c squared. Or oops, they want to call it the letter x. All right. Okay. 5 squared is 25. All right. And I'm going to put a little warning right here. Oop. That's kind of ugly. Not 10. All right. 5 squared is not 10. A lot of students make that mistake, and I totally understand why. 2 squared is foolproof. That is a 4 equals x squared. Oh my goodness. 25 plus 4 is 29 equals x squared. Ugh. Can I do anything with that? Not so much. All right. X is going to be the square root of 29. Now, what does that equal? I have no idea, but I can check that on my computer. If I had Alexa with me, I would ask her, but I got to type it into my computer. Square root 29. It's about 5.39. Okay. So this one is the right answer, this one is a close answer, and let's check it too. 5.39 is just a little bit longer than this 5. And I hope that makes sense to you, that this length is a little bit longer than this one. All right, cool. Ooh, that took up a lot of space. I'm going to do this to stay organized. All right, for the second one, there's my right angle. I have the square root of 8 here, y, and a 4. Okay, so we're trying to figure out what y is, and here I'm going to let a equals square root of 8. Now the long side is 4, so that's the c. All right, and that's kind of the b side. I always write the Pythagorean theorem before I start anything, okay, and then I start doing the substitutions. Square root of 8 squared plus y squared equals 4 squared. Okay. Aha, this is nice. Square root of 8 squared, that brings you back to a regular 8, plus y squared equals, oh my god, you know what's going to happen here, right? That's equal to 16. And again, a lot of sleepy students might make the mistake, so I'll put the warning here. 4 squared is not 8. Alright, it's not 4 times 2. Don't do it. It's 16. Alright, so now I'm solving for y. Minus 8 on both sides of the equation. That's 0. Y squared equals 8. Okay? And I'm going to take the square root of both sides and get y equals square root of 8. Interesting that this is exactly the same as that, coincidentally, for now. Alright? Thank you so much, and let's get to the next page.